they might get confused. So here we have our box here. This one is called a Stevenson screen. This box we normally use for keeping delicate weather instruments. We have our box here. This box is normally painted white. It's normally painted what? White. Why do we paint it white? Because white color reflects light and heat from the sun. White color reflects light and heat from what? From the sun. So the Stevenson screen, it is normally constructed using wood. It is normally constructed using wood because wood is a poor conductor of what? Heat. Because wood is a poor conductor of what? Heat. Around the board of a Stevenson screen, we normally provide with these openings. These openings are called the louvers. They are called what? Louvers. They are called the louvers. We normally put them here simply to allow easy circulation of what? Air. To allow easy circulation of what? Air. Now inside the Stevenson screen, we have thermometers. Inside the Stevenson screen, we have thermometers. It is mainly thermometers which are kept inside the Stevenson's what? Screen. You can have thermometers. You can also have a measuring cylinder. You can also have a thermohygrograph. So normally this thermometer, we have different types of thermometers.
Yes.
We have dry bulb thermometer.
Yes.
Maximum dry bulb thermometer.
Yes.
Wet bulb thermometer.
Yes.
Maximum thermometer.
Yes.
Minimum thermometer. A 60 thermometer. And a hygrometer. But all those ones, it is a repetition of these four here. The basic ones are only four. We have dry bulb thermometer and wet bulb thermometer. A hygrometer is a repetition of dry bulb and wet bulb thermometer. We also have a maximum thermometer and minimum thermometer. A 6 thermometer is a combination of maximum thermometer and minimum thermometer. So we have these four thermometers here. Dry bulb thermometer, this one records the temperature of air. It records the temperature of what? Air. That air which is passing through your ear, see?
Yeah.
It is what this one records. Dry bulb thermometer records the temperature of air. Wet bulb thermometer records the temperature of moisture in the air. It records the temperature of moisture in the air. Or it records the temperature at which water begins to evaporate. It records the temperature at which water begins to evaporate. Now maximum thermometer, this one records the highest temperatures reached in the day. Maximum thermometer records the highest temperatures reached in the day. Minimum thermometer records the lowest temperatures reached in a day. Have you understood me?
Yes.
So at the weather station, dry bulb thermometer and wet bulb thermometers, the readings are normally taken after every 30 minutes. The readings are taken after every 30 minutes. Why do we normally take those readings after every 30 minutes? We simply take these readings after every 30 minutes simply because we want to get what we call dew point temperature at that particular time. After getting dew point temperature, somebody goes ahead to get what we call relative humidity at that particular time. So we have four thermometers here. We have dry bulb thermometer. This one contains mercury. Wet bulb also contains mercury. Maximum also contains mercury, but minimum contains alcohol. Why do we normally use alcohol in minimum thermometer? The answer is alcohol. We normally use alcohol in minimum thermometer simply because alcohol has got a very low freezing point. It has got a low freezing what?
Point.
Point. Even when it is negative 10, negative 20 degrees, it is still records what? The temperatures. Whereas mercury, when it reaches below 10 degrees, it is simply freezes. You are getting me?
Yes.
Yeah. So, any question about these ones here? So, any question about this? So here inside you I normally record the temperatures. At the weather station we record the temperatures. We also record rainfall. We record what? Rainfall. And the instrument for recording rain, measuring rainfall, it is a rain gauge. It is called what? Rain gauge. This instrument here is called what? Rain gauge.
Rain gauge.
Yeah, this one here. This one is called a rain gauge. Yeah? This one is called what? A rain gauge. Now a rain gauge comprises or it consists of you stand up.
Stand there.
It consists of a funnel. This one is a funnel.
Yes.
And a collecting bottle. A funnel and a collecting bottle. In case the rain was too much and this bottle gets filled up, extra water will flow here. And this one is called an overflow can. It is called an overflow can. And this one is a metal case, yeah. Just a metal case, yeah. A house for it, yeah.
Yes.
Now after it has rained, now when it has rained, let me demonstrate it. Get some little water. I come and demonstrate. You remain there. It rained at night, eh?
Yes.
Water will enter through the funnel and it goes into what? Into the collecting bottle inside. Now the following day in the morning at 9 o'clock, somebody who is on duty will pick this measuring cylinder from the Stevenson's screen. When he picks it, he pulls out this funnel. He picks this bottle here. He pours this water until the last drop like this, eh?
Yes.
After putting it on the pouring on the measuring cylinder, he takes now the reading from here. It is in millimeters, huh?
Yes.
Like who can read for me this? It is how many? 3 point what?
5.
Huh? 3 point what?
5.
Okay, it is around 3.4, huh?
Yes.
It is 3.4 what? Millimeters. Now assuming this water was from the rain, if it had rained yesterday, and we measured it right now, you'll even go and tell your parents that that water which fell in Jinja yesterday, it entered into the soil by 3.40 millimeters. Have you understood me?
Yes.
It entered into the soil by 3.4 millimeters. Let us now move to the other one there. Is what a sunshine recorder. Eh? This one normally we use for, this one measures the duration of sunshine, the total number of sunshine hours received after every 12 hours. This one measures the total number of sunshine received in a day. Eh? It has a lens here and some cards. This one I forgot to bring the cards. It has one, but we are no longer using them. Eh? It has some cards inside the card here. Now when it begins shining in the morning, light rays enter from here because you put the card inside in the middle here. Now when they come here, when they enter in the morning, when it begins shining, they enter from here. They also come out from different points here, but they come and meet in the paper. They meet in the paper, so the paper will act as a focal what? A focal point. It will act as what? A focal point. Now when they meet in that paper, they create some heat. Out of that heat, it makes the paper to burn. Now in the morning, as the sun is on that direction there, it begins burning from here. As the sun goes up, it begins coming down here. As the sun goes down, it also begins burning, coming like this. I will show you those newspapers there. So go to green. So this one is for measuring the duration of what?
Over sun.
Yeah. exact opposite of a rain gauge. The other one is a rain gauge, but this one is an evaporation pan. Eh? This one is an evaporation what? Pan. This one measures the amount of water which is escaping back into the atmosphere. From where? From Lake Victoria, from River Nile, from the potholes on the road. We normally determine the amount of water which has gone back by the help of this instrument. It is called an evaporation water pan. Any question about this? It is an evaporation water pan. Cup counter anemometer. This one it has got two importances. You can use for measuring the speed of wind, or you can get the total wind run for the last 24 hours. But normally we use this one for measuring the total wind run for the last 24 hours. But whereas at the airfield here, we normally estimate the speed of wind. We just estimate. Yeah. So this one, anemometer, is supposed to go together with a wind vane. A wind, we shall go there. The wind vane is somewhere there. So this one is for measuring the speed of wind or measuring the wind run for the last 24 hours. The total wind run for the last 24 hours. It is what this one gives you. And we normally take this, when you take how you read it, at 9 o'clock you come and take these figures. Tomorrow again at 9 o'clock you come and take again. Get the difference of the figures you took today and yesterday. And this information is normally consumed by what? Ministry of Health. Ministry of Health. It can determine if the wind is very strong and the winds are moving very fast and there is a contagious disease, it can spread very fast. You can determine from here. Let us now go there. The element of weather we normally measure is atmospheric pressure. It is what? Atmospheric pressure. So we normally use a barometer for measuring atmospheric what? Pressure. This one is an aneroid barometer. It is called what? Aneroid barometer. We have different types of barometers. We have aneroid barometer, we have mercury barometer, and we also have digital barometer. But right now, we no longer use mercury barometer. We are using aneroid and digital. We don't use mercury these days because mercury is very, very harmful to a human being. If I drop mercury on your head when you don't know, it can infiltrate and go and damage your brain. Then some say that my child was bewitched. It destroys your brain and you run mad. It is mercury caused your madness when you don't know. You will blame that my neighbor bewitched me, yet it is mercury which killed you. So these days we use aneroid barometer and digital barometers. These ones are for measuring atmospheric pressure. Now, who is interested in atmospheric pressures? It is the pilot who is interested in in knowing the atmospheric pressure. Why does a pilot need to know about the atmospheric pressures? Without giving a pilot atmospheric pressures, he cannot land safely, or when he flies, he cannot know the height at which he has reached when he's going up there. If you have not given him the atmospheric pressure, he will fly, will go there, he will not even know that I've gone 2 kilometers. But when you have given him atmospheric pressures on the ground here, we will know that I've reached 500 meters, 1 kilometer, 1,500 meters, 2 kilometers, because of the help of atmospheric pressures from the ground. The same thing when he's coming to land at night. He doesn't see the ground. However dark it is, and you are given the pilot atmospheric pressures on the ground here, he will come and land very safely at night without any problem. But without you giving the atmospheric pressures, he will crash. So the pilot needs atmospheric pressures for safety precaution, for safety what?
Precaution.
Actually, it is supposed to be near the anemometer. They're supposed to be in one what? In one position. Yeah? They're supposed to be near each other. This one is a wind vane. Eh?
Yeah.
See that part which looks like an aeroplane? Eh?
Yes.
That is the part which is called what? A wind vane. Eh? It has got two components. You see where the propellers are?
Yeah.
That part is called a pointer. It is called what?
Pointer.
A pointer. It is called what? A pointer. Then this side here, it is the tail. It has a pointer and the tail. Now down here we have a compass direction. We have east, west, north and south. Are you seeing the compass direction?
Yes.
So the direction where the pointer is facing is the direction where the wind is coming from. Now who can tell me the direction where the wind is coming from?
South.
It is coming from the south going to the north.
Yes. Nice.
It is coming from the south. It keeps on changing, but it's coming from the southern part going to the northern part.
Yes.
Now down here we have those angle bars, those metallic angles.
Yeah.
Those metallic angles are just to hold it at a height of 10 meters above what? The ground. So wind direction and speed are normally determined at a height of 10 meters above what? The ground. And the units of wind, it is knots. The units of wind, it is knots, K-N-O-T. K-N-O-T.
Okay.
Knots, yeah. Yes. And the direction is normally, like now, if it is coming from the south, the component of wind, if you go to the true, from the true north, north is 0 degrees, east is 90, not so. South is 180. So if the speed of wind is around 5 knots and is coming from the south, you put 180.05 kt knots. That's how you report it. The component of wind, it has got both direction and speed. You mentioned both of them. So if it was coming from the east and the speed is 5 knots, you put 0.9005 knots. If it is coming from the south, from the north, you put 0.0005 knots. You are getting me? Yeah. So there we have a windy sock. Do you see the other one there?
Yes.
This one that close there. That one is a windy sock. That one is a windy sock.
Yeah.
That one is not found at the weather station, but is found at the airport. It is found at the airport. Now, who normally uses a windy sock? It is not a meteorologist, but a pilot. It is a pilot who uses what? A windy sock. Of which importance is a windy sock to the pilot? It has got two functions. One, it helps the pilot to estimate the strength of what? Wind. It helps the pilot to estimate the strength of what? Wind. Then the second one, it guides the pilot when he's taking off and also coming to land. It guides the pilot during takeoff and landing. As simple as that, yeah? So another element of weather we have not mentioned is the clouds. It is the clouds, and I'm going to give you, that one is the last. But I'm not going to give you, it is too detailed. We have 10 types of clouds. We have 10 types of clouds. That one you just write. We have low clouds, medium clouds, and high clouds. The low clouds, I give you the height. The low clouds are normally found from 1,500 feet. When you are going up, you measure in feet. 1,500 feet to 7,000 feet. 1,500 feet to 7,000 feet. I'm now going to give you from the lowest up to the highest. The low clouds, the lowest one is a stratus cloud, yes. Then the next one is a stratocumulus cloud. That one which normally gives rain in the evening. Stratocumulus cloud. Then the next one it is a cumulus cloud. That one is a cumulus cloud. This one there. Those are cumulus what? Clouds. Then the next one is height is a cumulonimbus cloud. That one which gives lightning and thunder. Yeah. Then we now go to the middle clouds. Those ones are normally found from 7,000 feet to 20,000 feet. 7,000 feet to 20,000 feet. Those clouds include nimbostratus. Unfortunately, nimbostratus is not common here. It is near large water bodies like the oceans.
You said that the middle clouds are found normally between what? 7,000?
7,000 to 20,000 feet. Those are middle clouds. Yeah. So I'm going to mention from the lowest, highest cloud. The lowest, the lowest middle cloud. It is nimbostratus. Nimbostratus, but they are not common here. Since I came here for the last 15 years, I've ever observed it only once. Yeah, they are not here. Nimbostratus. Yes. Then altostratus. Then altocumulus. That one is altocumulus cloud. You see the one which looks like a rib?
Yes.
Yeah, that is altocumulus what? Cloud. It is the only one which is in here, and the cumulus cloud. Then we have high clouds. The high clouds, those ones are normally found from 20,000 feet to 30,000 feet. 20,000 feet to 30,000 feet. Those ones include a cirrocumulus. A cirrocumulus. Cirrocumulus cloud is there. Totally there. A cirrocumulus cloud. A cirrostratus. And a cirrus. A cirrus. You see the other clouds which look like a thread? Yes. That is the cirrus cloud, and it is the highest cloud. A cirrus is the highest cloud, and the stratus is the lowest cloud in the atmosphere. And the stratus cloud is very stubborn. A stratus cloud is very stubborn, so that during rainy season, if it happens to be in the atmosphere and the ground loses heat at night, it has a tendency of coming down and sit on the ground. So that in the morning when you wake up, you find the whole place is covered with a thick fog. That is a stratus cloud which has descended into what? Okay. Into the ground.
How do they call it in vernacular?
Olufu. That one. The one which is thick, yeah, which has come down.
Okay.
Yeah, I think that is all. I cannot go beyond that.
Thank you so much, Patrick.
Yeah, welcome.
Thank you very much.
What's that?
That house there, it is a watchtower for security personnel. It is manned by the police.
Okay.
You know those days of Kaibura, the terrorists were after targeting the airport. So it is where the police will stand. When you is up there, you can see any corner of the airport.
Thank you.